Okay, hello and welcome back to Chemistry Talk. Today I'll be starting, we're continuing with acids and bases, but we're going to start with how to determine the pH. Um, you can determine the pH given many different concentrations. Today is going to be the easiest way to calculate pH, but other times you'll be calculating pHs of weak acids, weak bases, weak electrolytes, and that's more complicated. So this is a basic introduction to how we calculate pH. So pH, by definition, is the concentration of the hydrogen ion in solution. So to calculate the pH, you could take the negative log of the hydrogen ion concentration in a solution. The pOH is the measure of the OH concentration in a solution, meaning it's the measure of the hydroxide ion concentration in a solution. To calculate the pOH, you would take the negative log of the hydroxide ion concentration. Now, for aqueous solutions, there's a couple of things that we can state. Like I said, we just covered these two. The pH equals the negative log of the hydrogen ion concentration, and the pOH equals the negative log of the hydroxide ion concentration. It can also be said that the pH plus the pOH equals 14, meaning in an aqueous solution, your pH plus your hydrogen ion concentration, or your pH plus your pOH, your hydroxide ion concentration, how concentrated it is, have to equal 14. And that's what this is called up here. This is known as the water dissociation constant, and that's another video. But your hydrogen ion concentration per solution times your hydroxide ion concentration per solution should equal 14, or this 1 times 10 to the negative 14th water dissociation constant. So I think I have 3 examples or so of how this math would work. So this would be example 1. And what we are asked is to calculate the OH concentration, the pH, and the pOH for the following solution. So, and determine whether it's an acidic, basic, or neutral solution, and that will determine from the pH. So first thing I'm going to go after is the pH. And the pH equals the negative logarithm of the hydrogen ion concentration, and that we've been given. So the pH of this solution would equal the negative log of 5.0 times 10 to the negative 7th molar. So the pH of this solution is 6.3. So that would go here. We've just calculated the pH, which is 6.3. From the pH, we can get the pOH because I'll do back here, the pH plus the pOH equals 14. So 14 minus the pH would equal the pOH. pH here is 6.3. So 14 minus 6.3 gives us the pOH. So the pOH would equal 7.7. So notice that 6.3 plus 7.7 should equal your 14. Last thing we need to figure out is the hydroxide ion concentration of the solution. The hydroxide ion concentration of the solution would equal the pOH, which is equal to the negative log of the hydroxide ion concentration. So we know the pOH, but we don't know the hydroxide ion concentration. So what I need to do is take the inverse of the logarithm, the negative inverse, to cancel out the log and to cancel out the x. So I'm going to take this to the 10 to to the negative x power to cancel the logarithm and the negative. So 10 to the negative pOH 7.7 would equal your hydroxide ion concentration. So the hydroxide ion concentration equals 2.0 times 10 to the negative 8th. And that would go right here. And that's in molar. So is this an acidic, basic, or neutral solution? Well, the pH is less than 7, so it would be an acid because the pH is less than 7. Okay, calculate the hydroxide ion concentration, the hydrogen ion concentration, the pOH for the following solution, and then determine whether it's acidic, basic, or neutral. So first thing I'm going to do is calculate the pOH. And the pOH would equal 14 minus the pH. So 14 minus the pH, which is given, 10.7, would equal the pOH. So the pOH equals 3.3. From the pOH, I can get the hydroxide ion concentration. The pOH equals the negative log of the hydroxide ion concentration. I know the pOH, which is 3.3, but I don't know the x here, which is the hydroxide ion concentration. So you need to take the inverse of the log and the negative. So you're going to raise it to 10 to the negative x because you need to get rid of the negative and you need to get rid of the logarithm. So 10 to the negative 3.3 would equal your OH concentration. So the OH concentration here equals 5.0 times 10 to the negative 4th molar. That would go right here. Okay, last thing we need to do is find the hydrogen ion concentration. Well, that's very similar to what we just did for the OH concentration. The pH equals the negative log of the hydroxide ion concentration. So when you raise the pH 10.7 to the negative 10th, you're canceling out the negative log, and you're canceling out, you're just canceling out the negative log by raising it to the 10 to the negative power. So you get your hydrogen ion concentration to be 2.0 times 10 to the negative 11th molar. So finding the hydroxide ion concentration and finding the hydrogen ion concentration are very similar. You're just using the pH versus the pOH. So is this solution acidic, basic, or neutral? Well, the pH, change colors here. The pH is greater than 7, so that means it would be basic. Okay, last question here. Calculate the hydroxide ion concentration, the hydrogen ion concentration, and the pH of this solution from the pOH. So here we were calculating the pOH from the pH. Now we're going to calculate the pH from the pOH. So the pH would equal 14 minus the pOH. So 14 minus 2.3 is going to equal the pH. And that's going to equal 3.3. Sorry, no, my bad. 11.7. I was looking at the wrong thing. 11.7. 14 minus the pOH will give us the pH, and that's 11.7. Because that did not make sense before. So that's the pH. Now to find these two concentrations, you're just taking the inverse of the log. So the inverse log of the pH would equal the hydroxide ion concentration, and the inverse log, negative log of the pOH would equal the hydroxide ion concentration. So when you do the math there, you get the hydroxide ion concentration to once again be 5.0, but times 10 to the negative third molar. And when you take the when you take the inverse negative log of the hydrogen ion concentration, you get 2.0 times 10 to the 12th, negative 12th molar. So the pH is greater than 7, so this is a base. So I hope this helped you to understand how pH, pOH, and hydroxide ion concentrations and hydrogen ion concentrations are calculated. Future videos will be doing more tough calculations with pH.